Alright, in this lesson we will continue our study of the normal distribution. Please understand that we've talked about two different things so far. We talked about the normal curve and the percentages, where we memorized that this section would be 34% and this would be 13.5% and this would be 2.35% and so on, 0.15%. And if this is going to be the mean, then each one of these is going to be one standard deviation. So this would be one standard deviation away, this would be two standard deviations, and three. So when we first started learning about this, this is what we did. And all the numbers came out nice and even, and they would land on exactly 1, 2, or 3 standard deviations in either to the left or to the right. But then we got away from that and we started looking at what about all the decimals in between. What if it was instead of 1 standard deviation, what if it was 1.5 standard deviations or 1.3 standard deviations? Okay, what if we had something in between? Now what do? Now how do I figure out what percent this is if it's not one of the ones that we memorized? Alright, and then that's when we were doing this with the little chart to help us figure it out, and that's when we were using the z-score table like this. Okay, so please understand that we've done those two different things. Nice even standard deviations, and then the more messy decimals in between where we use the table and the formula that said z-score is the value minus the mean divided by the standard deviation. So obviously when you put it all together for a review, you're going to have to be prepared to do both of those different types of things. So that's what's happening. Alright, so problem number 1 is that original type where we're going to do the percents, and everything is going to start off nice and even, so be ready for that. It's been a few days since we've worked on that. Alright, so problem number 1, we need to draw the normal distribution and label 1, 2, 3 standard deviations. We're supposed to fill in the percentages for each section, and we're told that the mean is 21 and the standard deviation is 1.5. Alright, so basically we're being asked to do what we first learned to do. Okay, well the mean we know goes right in the middle. Oh, by the way, I went ahead and drew this for you, but you should be prepared to continue drawing this yourself like you've done many times before. Mean of 21, so that's going to go right in the middle. Okay, there's our mean of 21. Now, because the standard deviation is 1.5, as I go to the right, I'm going to increase by 1.5 because each one of these lines represents one standard deviation more. Okay, so this is going to be 22.5, and this is going to be 24, and this is going to be 25.5. Now, as I subtract 1.5 each time moving to the left, first I'm going to arrive at 19.5, and then 18, and then 16.5. Okay, so problem number 1, oh yeah, so fill in the percentages. So let's go ahead and do that. Okay, so like I started showing you before, we learned that this section was 34% and this was 13.5% and this was 2.35% and this is 0.15%. And of course this is a mirror image, so it'll be the same thing. Whoops. 34%, 13.5%. Okay, 2.35%, and 0.15%. Okay, as long as I'm talking about it, let me also mention that we memorized these three intervals as well. If we go out one standard deviation in both directions, we learned that that was 68%. All right, that one's easy to see because 34 plus 34. All right, but we also learned that if we go out two standard deviations in both directions, okay, we should memorize that this is 95%. Okay, just memorize that. The middle 95%, that's two standard deviations in both directions. And we also memorized what you would get if you went three standard deviations in both directions. Okay, we learned that that was 99.7% of all the data. All right, of course you could get all those numbers by adding up the smaller numbers, but it will give you a better understanding if you have those three values memorized as well. So that was number one, is just drawing this picture. Okay, number two, using your picture above, what percent of people watch more than 22 hours of TV per week? Sorry, more than 22.5. So please start with your symbols. Okay, so more than 22.5. So we're talking about the proportion of x values that are greater than 22.5. Okay, always start with your symbols. Okay, and picture-wise, all right, greater than 22.5 is going to be this area in here. So you could just count up these three percentages, and I believe you're going to get 16%. Okay, yeah, just add up these three percentages, and you will find that that is 16%. Okay, great. Using your picture above, what percent of people watch between 16.5 and 24 hours of TV? And, I'm just going to keep it over here where I can see the picture. Okay, again, start with your proportion. So we're talking about the proportion of x values that are between 16.5 and 24. Okay, and the way we do between, might not have left enough space, is we say, okay, fine, 16.5 is less than x, which is less than 24. Okay, anyway, so finding out what that is. Alright, so 16.5 is here, and 24 is there. So one thing we could do is we could add up all of these numbers, 1, 2, 3, 4, 5 numbers. Okay, another thing we could do is we've memorized that the middle, this is the middle 95%, as you recall. Okay, because that's two standard deviations in both directions. So you could take this middle 95% and then just add the 2.35 to it. Okay, so that's going to be 97.35. Okay, one more way you could look at it. That last one, that's probably the easiest way. Yeah, I'll just stick with that. Alright, anyway, 97.35%. Okay, looking at number 4. Using your picture above, what percentage of people watch less than 18 hours of TV per week. All right, less than 18 hours. So we're talking about the probability that X is less than 18. Okay, let me go back to yellow. So here's 18, so less than 18 is going to be to the left here. So just add up those two numbers, and that's going to be 2.5%. Alright, number 5 is asking us to use a z-score and a z-score table to find the percent of people that watch less than 18 hours of TV per week. Okay, so we already know that the answer should be 2.5 based on this analysis that we just did. Alright, because 18 happened to be an even value. In the past, we've been using our z-scores and the z-score table to handle it when the values are in between these numbers, when it doesn't turn out to be an even standard deviation. But the procedure of using z-scores should work for any value, including the ones that come out nice and even. So it's a good way for us to make a connection between what we learned first and what we learned second. Alright, so yeah, let's do this problem both ways and verify that we're getting the same answer. It'll make maybe more sense to you now. Okay, like what we've been doing. So z-score. So the z-score formula is this. The z-score is going to equal the x value minus the mean divided by the standard deviation. Okay, so let's start with that, and let's turn this value of 18 into a z-score. Let's standardize it. So the z-score should equal 18 minus the mean, which was 21, divided by the standard deviation, which is 1.5. Okay, so that is going to give me my z-score. Let's see, so we've got 18 minus 21 divided by 1.5. Alright, so that's giving me a z-score of -2. Alright, of course, we knew that it was going to be -2 because, you know, it's 2 standard deviations to the left. Okay, this is -2 standard deviations right here. Okay, and that's what z-score is. It's how many standard deviations you are to the left or right. So we knew it was going to be -2, or we should have known. Anyway, so using a z-score to find a percentage means you go to the table and you find your z-score and then you find your percentage. Okay, so with a z-score of -2, okay, then we are looking at this percentage right here. Okay, 0.0228. Okay, so that corresponds to, okay, so the proportion of z-scores that are less than -2 are what did it say? 0.0228. 0.0228. And which, of course, as a percentage would be 2.28%. Okay, so that's really close to the 2.5%, but it's not exactly correct. And I think that's because these are estimations and they don't 100% match in the way they do their calculation, but they are close enough for this kind of estimation. Alright, so the question asks, is your answer different from number 4? And so we will say it is a bit different, but close. All right, with that, let's move on to number 6. Can you use your picture from number 1 to find the percent of people that watch fewer than 20 hours per week? Let's see. No, we cannot, because 20 is not one of the values that's exactly 1, 2, or 3 standard deviations away. It's a little bit off. So that's where this picture fails us. Okay, so we will say no, 20 is not exactly 1, 2, or 3 standard deviations from the mean. Okay, and that's all that picture is good for. Okay, so if I want to find what percent of people watch fewer than 20 hours per week, that's when we do the analysis that we've been doing with the 4 squares here. Alright, so we're going to show all steps, include the sketches. In other words, we're going to do what we've been practicing the last 3 days. Okay, so here we go. The percentage of people that watch fewer than 20 hours a week. So let's go back to drawing our sketches. Okay, so we know that the mean is 21, so that's going to go here. Alright, we want fewer than 20 hours, so that's going to be over here. Alright, a little bit to the left. Okay, it's going to be hard to write the 20 that close, but there it is. Alright, 20. And we want fewer than 20, so of course we're going to shade to the left for that reason. Okay, and so this is hours, so let's definitely label that. Okay, and so we're looking for this percent. We don't know what it is. Now we'll do the same thing over here, but instead of hours, we're going to do z-score. So I'm just going to put z because I don't know what that is yet. Okay, and I'm going to label this z-scores. Mandatory. If you don't put that, you're going to lose points. Okay, same with the hours. That's mandatory. Okay, so here we are shading to the left of this. So, oh yeah, in the middle, instead of mean, alright, the middle z-score is always 0. Okay, so far so good. Now we will use z-scores to find the percentages. And we will do that by using our little z-score formula. Alright, we know that z-score is the mean, the z-score is the value minus the mean divided by the standard deviation. So that means our z-score is going to be 20 minus 21 divided by 1.5. So that means our z-score is going to be negative 0. And now if I'm looking at the calculator, it's like 6666666. Okay, but the z-score is only going to be helpful on the table for 2 decimals worth. Okay, so I'm going to have to cut it and round properly at 2 decimal places. So if I cut it here, so the question is, do I keep this a 6 or do I round that up to a 7? And of course that depends on what the next number is. So we can forget all these numbers. Okay, if this number is 5 or greater, then we round this up. So since that is a 6, we will round this up to a 7. And that is a lesson on how you round properly. 'Cause some of you apparently need that lesson, so you're welcome. So now we have our z-score. So let's go ahead and put that negative 0.67 in full effect. Okay, so this is negative 0.67 z-score. Now we will use the table to find the proper proportions. Okay, we will start with our symbols. So, we are looking for the proportion of z-scores that are to the left of negative 0.67. We're looking for this. So the proportion of z-scores to the left of negative 0.67, well, that's what this table is all about. This table always gives you the proportion to the left of a certain z-score. All you gotta do is find it. So, no, not that one. Yeah, why not? Our z-score is negative 0.67, 0.67. So because it's negative, make sure you're on the negative side of the paper. Okay, now I'm looking for 0.6. Okay, so I'm starting here. This is our negative 0.6. For the 7, the 7 in 0.67 gives me the column. So this is column 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the proportion that I'm looking for. So 0.2514. Okay, so that is the proportion of z values that are to the left of this number. Okay, but that is this proportion. Of course, as a percentage, that is 25.14%. Okay, so that means this area of the curve represents 25.14% of the data. Okay, and that should be the same percentage for x values. So this is also 25.14% of the data. And that's what we were looking for. And so now that we know that 25.14% of the hours of TV watched are less than 20, we can write our answer as a complete sentence. I like to read the question and then sort of reflect the question back in my answer. So what percent of people watch fewer than 20 hours per week? Well, turns out that 25.14% of people watch fewer watch fewer than 20 hours of TV per week. I missed an L there. Oh, you know what? My L is not working properly. It's going to happen a lot. I need a new computer. Okay, and that's it. That's how you do these types of problems. Alright, so that was number 7. Let us move on to number 8, my friends. What percent of people watch more than 23 hours per week? Okay, again, let's start with our pictures. Alright, let's start off with the hours. So 23, so that's going to be over here somewhere. Okay, so there's 23 hours. Alright, make sure you give your units. And we want more than 23 hours. So we're going to shade this part of the graph. Okay, great. And z-score is the same thing. Alright, we don't know what the z-score is yet, but once again, more then this z-score will be to the right. Okay, now let's move on to our calculations. Let's once again start by finding out what the z-score is so that we can use our table to find the right proportion and percent. Okay, so the z-score, using our formula that the z-score is the value minus the mean divided by the standard deviation, the z-score this time should be 23 minus 21 divided by 1.5. So that gives us a z-score of, that's giving me positive 1.333333. Again, I've got to cut it here. I'm looking at the next number after the cutoff. If that's 5 or higher, I'm going to raise this up. If it's less than 5, I'm going to leave it alone. Since this is a 3, I'm going to leave it at this. There's another lesson on how to round properly for those of you who needed it. So what we are looking for is the proportion of z values that are greater than 1 point, oh yeah, let's put this in the picture. So the z value is 1.33. Let's put this in the picture here. 1.33. Alright, yes, so we are looking for the proportion of z values that are greater than 1.33. But there's a problem here. You got to be very careful right now. This table of values does not give me the proportion of values that are greater than the z-score. It only gives me the proportion of values that are less than any given z-score. These are all less than values. They are not greater than values. So it's sort of like this. I'm going to show it as an extra step because a lot of kids are getting confused and they're trying to copy me as best they can, but they don't really know what they're doing. Hold on. Alright, so I've got a z-score of 1.33. Alright, I erased what I had before just for a second. Now what I'm about to write now, you don't have to show. This is an extra step. I'll show it in purple. You can skip this. Okay, but what you need to understand is the table that I'm about to use only does less than. So if I want to use a z-score of 1.33, the table is going to give me the proportion of z-scores that are less than 1.33. That's all the table can do is less than. It has no, that's all it is. So if I use the table and I find my value, so here I go, positive 1.33, so I need to be on the positive side of the chart. So here's 1.3. So this is 1.30, 1, 2, 3. Okay, so this is the proportion off the table, 0.9082. Okay, so this is 0.9082. Okay, but what you need to understand is this is the proportion of z values that are less than 1.33. If I want the proportion that's greater than, and this is what I usually have you write down, if I want to change this and do the proportion of z values that are greater than 1.33, then I need to subtract from 1 to find the other, to find the right hand side. So if I do 1 minus 0.9082, then that'll switch it from being the proportion on the left to now giving me the proportion on the right. Okay, and so that's giving me 0.0918. Okay, so that will be the proportion that's to the right. And as a percent, this would be 9.18%. Okay, and that's what we were looking for. Look, just put one more way. As far as what we're doing is, because a lot of kids are just like, why do we subtract from 1 and when do we subtract from 1? I don't get it. Just please understand that when we use that z chart and we got this number, okay, you understand that this is 90.82%, right? So all you have to understand is that 90.82%, that's automatically the left side of the picture. Okay, because the z-score chart only does left. That's all it knows. So when we looked up that value and we got 90.82%, it was giving us this side of the picture, 90.82%. It was giving us the left, but the left is not what we wanted. So if you have the left from the chart and you really want the right, what would you do? Okay, well, if you're dealing with percentages, you would subtract from 100, right? Because you know the entire graph here is 100%. So if you did 100% minus 90.82%, which we got off the chart, which had to be the left side, if you wanted the right side, let's see, 100 minus 90.82, oh look, that's 9.18%. Okay, and that's what we just got by doing 1 minus this little decimal. Okay, so if it helps you to keep it as percents and go, okay, first I'm getting 90.82%, but that's the left side, so since I want the right side, I need to subtract from 100. If you'd rather do it in percents rather than just doing 1 minus 0.9082, either way it's the same thing. Anyway, it's time for the sentence. Okay, so the sentence is, oh yeah, I like to look back at the question. What percent of people watch more than 23 hours per week? .18% of people watch more than 23 hours of TV per week. Alright, that's it. Alright, here's how it all looked from a bird's eye view. Guess I can get rid of some of this now. Okay, and there it is. Oh well, I'll deal with that later. Alright, let's move on to number 9. What percent of people watch more than 24.5 hours per week? Alright, well, no one should be watching this because this is exactly like number 8. So I already just showed you how to do it. So there's no need for you to watch me do it again. I'm going to do it again. I don't even know why. OCD, I guess, but you should already know how to do it. So everyone should be doing it themselves, getting the right answer, and skipping this whole video. This should be a waste of my time. Alright, since number 9 is just like number 8, I'm going to go through this as fast as I can. So 24.5 hours, okay, 24.5 hours. What percent watch more than this? That's going to be this area over here. Okay, z-score, same deal. Alright, some kind of z-score over here, area to the right still. We will find the z-score using our z-score formula. Z equals the value minus the mean divided by the standard deviation. So that's going to be 24.5 minus 21 divided by 1.5. So that's going to give us Okay, 2.33. Okay. Now, if I want the proportion of z-scores that are greater than 2.33, I'm going to have to do 1 minus whatever I find on the chart, because the chart only does less than. Alright, to get the greater than part, I need to subtract from 1. Meanwhile, let's put 1.33 in its place of honor on the picture. Now, to the chart to find that proportion. Alright, did I just put 1.33? I sure did. .33. Okay, now, oh, that's why. Alright, to the chart. Now, we're not doing 1.3 anything. We're doing 2.33. So here's 2.3, 2.30, 1, 2, 3 would be here. So that's 0.9901. Okay, so that is the proportion of z values to the left is 0.9901. All right, as you can see, most of the z values will be to the left of that number. So that's going to give me 0.0099, which as a percent, if I move this, it's going to be 0.99%. It's a really tiny amount. It's almost 1%. But bam, that's the percent. So let's put that in the picture. I feel like I was forgetting to do this before. So that means we were just doing z-scores, so I should start over here. So that's 0.99% of the values are over here, which also means that 0.99% of the values are over here. I feel like I forgot to put those percentages on the previous problems. Did I? Okay. Well, what is all this? Okay, I put it on the z-score chart, but I should have put it over here too, because this is like the final answer when we bring it back to hours. So yeah, 9.18. Did I do it on the last one? Okay, this one I did it on both charts as I should. Always put that percentage on both charts in the end, showing the connection between the z-scores and the actual values of interest. Okay, so anyway, we're ready to answer with a complete sentence. What percentage of people watch more than 24.5 hours a week? Okay, 0.99% of people watch more than 24.5 hours of TV per week. Okay, that is it for that one. Okay, number 9. Number 10. What percent of people watch between 19 and 23 hours per week? Okay, so we have two values to deal with, 19 and 23. So fine. So 19, just put over here somewhere, and 23 will be somewhere on the other side. Alright, and we want the percent of the people to watch between this many hours. So we will shade in between those numbers. And we will do a similar effect on the z-score picture. Okay, we don't know these values yet, so I will call them z1 and z2 for now. But again, it's what's the percent between these values that matters. Okay, so we are going to have to do our z-score calculation twice. So our first z value corresponds to the 19. So I will do 19 minus 21 divided by 1.5. Alright, and that is going to give me negative 1.33 for z-score number 1. Alright, for z-score number 2, it's going to come from the 23. So I'm going to do 23 minus 21 over 1.5. Okay, and that's going to give me positive 1.33. Okay, let's go ahead and put those values on our z-score chart. Okay, so we have negative 1.33 on the left and positive 1.33 on the right. Okay, so we want the proportion of z-scores that are between these two. So we want this. We want the proportion of z-scores. So I would have to write negative 1.33 is less than z, which is less than positive 1.33. That is what we are looking for. Alright, so we're going to go to the z-score table, but just understand that the proportions that we're going to get between these two z-scores, we're going to need the difference. We're going to wind up subtracting the two values to find the proportion between the two. So it'll be the bigger one minus the smaller one. So let's start with positive 1.33. Okay, so if I start with positive 1.33, so here's positive 1.3. So this is 1.30, 1, 2, 3. So that's our 0.9082. So we will be doing 0.9082 minus the proportion to the left of this z-score. So now let's go to negative 1.33. So there's negative 1.3. Okay, negative 1.30, 1, 2, 3. So that's 0.0918. 0.0918. So if I subtract these two, that's going to give me the proportion between these two z values. Alright, it's the difference. So just put that in your calculator. So that'll be 0.8164, which as a percent would be 81.64%. Okay? Alright, and let's record that on both the z-score picture and the hours picture. Okay, so now as a complete sentence, we can say the following. Okay, so 81.64% of people watch between 19 and 23 hours of TV per week. Alright, that's it for this problem. Alright, let's move on to number 11. Alright, what percent of people watch between 17 and 21 hours a week? Well, this is the same thing like we just did for number 10. So again, no one should really be watching number 11. This should be a waste of my time because everyone should turn off the video, do number 10 by themselves. You're going to get the right answer, and so why are you watching the video? Alright, but I'm going to make the video anyway because I'm crazy like that. Okay, between 17 and 21 hours. Okay, so find 17, let's put 17 over here somewhere, and 21 hours is the mean, so there's already a line there for that. So once again, between is going to be in this area right here, so we will just shade that up. Okay, and let's do a similar thing for z-score. Just drop a line over here. I don't know what it is. The mean we know is a 0 z-score, so that's one z-score that we don't need to find. Okay, we just need the 1. Okay, so now we will do our calculations and we will find that z-score, the one from the 17. So the z-score is going to be the value minus the mean divided by the standard deviation. Alright, that's giving me negative 2.6 repeating, so I'm going to round that to negative 2.67, rounding up properly. Okay, so there's my z-score. Let's go ahead and record that on the picture, the z-score picture. Alright, so negative 2.67, so that's more than 2 standard deviations to the left. Alright, it's coming up on 3 standard deviations to the left. Anyway, so if I want the proportion of z-scores that are between these two z-scores that I have right here, so I'm looking for the proportion where negative 2.67 is less than z, which is less than 0 in this case. I used z last time, didn't I? Yeah. Okay, that's what I'm looking for. Okay, now when I have two z-scores like this and I want to find the proportion between them, I'm going to wind up subtracting the larger one minus the smaller one. So 0 is actually the larger one. So I'm going to start with a z-score of 0. I really don't need a chart for this because I know that 0 is 50% of the graph. Alright, 50% of the graph is to the left of 0. It's just like 50% of the graph is to the left of the mean. But if you were to just ignore that and look for 0, wait a minute. Oh look, 0.5, alright, 50%, big surprise. So we will do that. So I have 0.5 minus, okay, now we will look for the proportion to the left of negative 2.67, alright, we're going to be finding this little white area here if you want to be accurate about it. So negative 2.67, hold on, let me delete some of this trash. Okay, so here's negative 2.6. So we need negative 2.67. So this is negative 2.60, 1, 2, 3, 4, 5, 6, 7. Because I could have just looked up there. But there it is. Okay, so that's 0.0038. Okay, so let's subtract, and I'm getting 0.4962. Alright, and of course that is 49.62% of the data. Alright, so that's going to be the same percentage in both pictures. Let's go ahead and include it. Alright, so 49.62% of the hours are between 17 and 21, and 49.62% of the z-scores are between negative 2.67 and 0. Anyway, one more time, we can write this as a sentence. I don't know what's happening. So 49.62% of people watch between 17 and 21 hours of TV per week. Alright, and that is it for me in this video, my good people. I hope this video has been helpful to you. Hope you didn't just copy stuff off of me, because that won't really help you. And I will see you on the next video, my good people. Peace out.